Hey everybody, this is Mr. McKee with Net 225. Today I'm going to be going over Packet Tracer 5.1.9, which is Investigate STP Loop Prevention. Alright, so first thing I'm going to do though, I'm going to go ahead and reset this activity. Alright, so I'm there. Packet Tracer's here and here. Alright, so what I want to do though, see how got three switches, multiple paths from PC to PC. Nothing's converged yet. It's still working. All right, now I'm going to fast forward though and watch certain things are going to turn green. All right, so we see that one's still orange or amber, one interface, and everything else is green. All right, so the big thing you want to do when you have multiple switches connect together in multiple paths, if you say if these were all the old school hubs, you would be getting a broadcast storm, which it would keep forwarding out. Or if you had switches with that didn't have spanning tree protocol installed on them or running, you can have one switch forwarding out. It's like say if PC1 sends a packet out, switch 1 forwards it out, and then S2 gets it, it forwards it out the other interfaces where it didn't come in. Wherever it comes in at, it doesn't switch doesn't forward out that interface, but it forwards out the other interfaces until it learns what MAC address is the ingress port. You know, say if PC1 S1 in its MAC table will record that hey, PC1 is this MAC address, and then it'll know from then on that if I'm looking to send a frame to that MAC address, that's the port I'm going to go in. But if you don't have that though, you're going to keep recycling data packets across the network. All right, so spanning tree protocol prevents that. You can have a redundant link. So if say if this right now from PC1 to PC2, this is the link right here. All right, say if this link got cut for some reason, it would change the path from PC1 to S1 up to S3, S2, and then to PC2. All right, so we're going to show you in this packet tracer how to do that. All right, so let's do this. All right, so what we want to do first, let's take a look. All right, verify connectivity. Ping from PC1 to PC2 to verify connectivity between the hosts. All right, and we know the IP address right there. So let's ping PC2, which is 192.168.101. All right. So what we want to do now is use the show spanning tree VLAN1 command to gather information about the spanning tree status of each switch. Complete the table below. For the purposes of this activity, only consider information about the gigabit trunk ports. The fast Ethernet ports are access ports, and they have end devices connected and are not part of the inner switch trunk-based spanning tree. Okay, so the big thing we're going to worry about is the trunk ports going between each of the switches. All right, so let's look at this first thing. Look at this, and I'm going to provide you guys with a Word document so you can fill in this table really easily. But here's what you need to do. All right, let's open up switch 1. You see it's giving you a bunch of information here. Privilege exec. Go to show spanning tree VLAN1. All right, there's that one. Let's click 2. Enable show spanning tree VLAN1. And if you notice, I'm not typing in the whole entire thing. That's 2. This is 3. All right, so I'm doing show span SPA, and I'm hitting tab VLAN 1. All right, so looking here, we can see we're in VLAN 1, which is VLAN 0001. All right, it tells you about the root ID, priority, cost, port, the physical port on the switch. All right. Things like that. What you want to look for though, if you want to figure out if it's the root bridge or the root switch, the root ID and the bridge ID will be the same. And what you want to look at is the actual MAC address being the same. All right, so I've got that one. Let me see if I can get all these up on the screen at the same time. No, I can't. Let's see if I can do this. All right. So we want to look for that. This will be a little tricky. Let's do this one. All right, so that's 1, 2, and 3. All right, and we can see right here. let's look at what's on 1 first. All right, so 1, we're on VLAN 1. All right, if we look down here, our interfaces, it said disregard the fast Ethernet right there. Don't worry about that. So we have a root, which it's telling us the default route. Now, based on the cost, it's actually calculated what's the closest route. Instead of going S1, S3, S2 to PC2, we want to go S1, S2 to PC2. All right. And if you notice right here too, that's an indicator that that's a block port. All right, so we got, and we can tell these are forwarding, so it's forwarding traffic out. So it's S1 gigabit 02 is the root port. All right, and then this is like the designated port, which is gigabit 01, which means we can use that, but we're not going to use it right now. It's currently not doing anything for us. All right, so let's go over to, let's actually go to switch 3. All right, so switch 3, make sure we're on VLAN 1, which we are. Let's see. This is telling us what port we're using and the MAC address of it. All right, so we have 2 interfaces on this switch, part of the VLAN 1, which gigabit 02 is an alternate port, and also it's blocked. BLK is blocked status. All right, so it's not sending any traffic right now. Now gigabit 01, that's a root port. So that's actually going to the root. This isn't the root switch or the root bridge, but it's going to the root. So gigabit 01 on this one's going to the root. Let's go S1, gigabit 02. That one's going to the root. All right. And now switch 2, if you notice, we're on VLAN 1. I'll like to check that first. All right. The root ID, all right, that interface, that MAC address is the same as the bridge ID. All right, so this is the switch 2 is the root bridge. All right, and we can see right here we're using gigabit 01, gigabit 02. All right, and then it has FA01, but that goes to a PC, so we're not going to worry about that. So right now it's going PC1 to switch 1 to switch 2 to PC2, and then reverse PC2, switch 2, switch 1, PC1. All right, so now we know where everything's going. So if we go to switch, if we fill in, I'm not going to fill this in for you guys because you guys should be able to look at it, but switch 1, gigabit 01, all right, it's forwarding status, root bridge, no. And hang on one second, let me click on something. Where did it go? All right, gigabit 01, that's forwarding. That's not the root bridge. Gigabit 02, that has a root role, or a forwarding role. Is that the root bridge? No. Now it does, it's kind of complicated because that one has a root role on that gigabit 02, but the root bridge would still be this one right here. And you can tell this, it says right here, this bridge is the root. All right. So S2, gigabit 01 is forward. Gigabit 02 is forward. Is it a root bridge? Yes, yes. And S3, gigabit 01, it's in forward, not a root bridge. Gigabit 02, it's gigabit 02 is blocking. All right, so then that's why you see this light right here. That's why you see that light. It's blocking. That port's blocking. Because what you want to do, it'll keep broadcasting frames around the network indefinitely, so it'll slow down the whole network. So what it does, it automatically figures out that there's two possible paths, so it blocks one of those. The one it blocks is the one that has the highest cost. Okay. People that stopped emailing me. All right, so let's see. Packet tracer uses different link light on one of the connections between the switches. What do you think this link light means? Well, I just told you. What path will frames take from PC1 to PC2? You guys should know that one. Why did the frames not travel through S3? Well, looking up here, if I can click on it. All right, it's because that port's blocked. Gigabit 02 on S3. All right, why is spanning tree placed a port in blocking state? Well, so it doesn't have, you don't create broadcast storms. All right, so remove the connection between S1 and S2. And the way I'm going to do that, up here it has delete. No, cancel. Like that. You want to delete it. Oh. Let me undo that. Alright, so I got this X is for delete. So if I click S1 to S2, click that, and I hit escape, I get my pointer back. Alright, so now it's going to start telling us something's happening. Alright, it's telling us this interface is down. Gigabit 01 on S2, which is right there, it's down. Let's see, where'd my S1 go? So S2's gigabit 01 went down. S1's gigabit 02 is down. All right. I can go back to all these. And if we do fast forward, you notice that it unblocks that port. Now S3 is now, let's do up arrow, showing VLAN 1. Alright, so now gigabit 02 instead of blocking is forwarding traffic. So now my path would be PC1 to S1 to S3, S2, and PC2. All right. And then these other ones, let's see. And see, we've actually lost gigabit 01 from this VLAN 1, the spanning tree table. All right, it's just disappeared. And the same thing with S1. Let's see. Let's do enable show spanning tree VLAN 1. So it's forgotten what the gigabit 02 was once a part of that VLAN. Not VLAN, spanning tree and the VLAN. All right. So that shows you what's going on. Let's see. So observe spanning tree convergence. Quickly return to the CLI prompt on switch 3 and show the VLAN, the spanning tree VLAN 1 command. Use the up arrow key to recall the spanning tree VLAN 1 command and issue it repeatedly until the orange blink light on the cable turns green. Observe the status of port gigabit 02. So it's talking about S3. All right. So that was showing blocks as the status, and now it's showing forwarded. All right. So what do you see happen to the status of gigabit 02 port during the process? Well, it turns to forwarding, and the little light turns green on packet tracer. All right. You have observed the transition in port status that occurs as a spanning tree port moves from blocking to forwarding state. Verify the connectivity by pinging from PC1 to PC2. If we can up arrow. All right, still have a connection even though our path has been broken, our original path. All right, so let's see. Verify connectivity. Oh, we already did that. Are any ports showing a orange link light that indicates that the port is in spanning tree other than forwarding? Why or why not? You guys could answer that, but if you look at the screen, I don't see any. And the reason being, we cut that port, or we cut that cable out of there. And that's it. Now for this this week, I'll actually put a Word document on in Moodle, all right, and you'll fill in the table and then answer these questions. 1, 2, 3, 4, 5, 6 questions. All right, and you don't have to submit the packet tracer. All right, but if we want to get back to where we were in the beginning, we can do undo. All right, puts this back in there. And if we do fast forward, we go back to a blocking state on gigabit 02 of S3, which is right here. If we do that again, all right, so now it's back to blocking at the status, and it was forwarding. So that's pretty much it. It doesn't seem super cool, but it definitely is cool if you don't have that, because if you hook, say if you want a redundant link in case one gets cut, you want it to take another route. If you don't have a spanning tree protocol in here, that's going to create a bunch of issues on the network, and it's going to slow down a bunch. All right, so pretty much I'm going to put a Word document on Moodle. You guys fill that out and submit it for grade. All right, and make sure when your answers, make sure to put those in either blue or red text so I can easily distinguish those from the packet tracer text. All right, thanks for watching.